Once again, I'll begin with putting some faces to names with the 4 co-authors. And continuing with the same outline slide, the first webinar introduced the scoping review completed in June of 2011. It's not been possible to stay on top of the literature we addressed in the scoping review, so we have tried to keep track of the literature on endocrine disruption, and therein have focused on environmental links to obesity and diabetes, the focus of the second webinar. We also didn't address policy issues in the scoping review, so like the second webinar, I'm aiming to bring us up to date today in terms of policy implications arising from this very large topic. So I'm going to begin with a recap of our main findings and then review some key challenges in evaluating evidence in environmental cases. And I'm going to aim to speak for about 25 minutes and then pass the floor to each of my co-authors. Next slide. So to recap our main findings, there is indeed evidence linking early environmental exposures, most often prenatal exposures, with the later development of certain chronic diseases, though many knowledge gaps remain. Each of the chronic diseases we looked at, we also found limited to no recognition of environmental exposures in broader considerations of chronic disease risk factors. The developmental origins of health and disease, or the DOHAD concept, is based on a very solid evidence base that is rapidly expanding to include early life exposures. And going beyond the obvious and well-known chronic disease risk factors, so diet, activity levels, smoking, alcohol, we need to put this information into a broad and systemic context. Changes have occurred over the last 3 to 4 decades, much faster than changes can happen in our genetic makeup, in parallel with the rise in chronic disease, and these trends need to be considered when looking at chronic disease, including multiple interactions. Within the continuum of shared, well-known risk factors across several chronic diseases, we note the primary importance of the social determinants of health. And this reality of shared risk factors points to the likelihood that environmental risk factors are also shared across multiple chronic diseases. And finally, a wide range of chemicals or pollutants are implicated as early life risk factors, with many arising frequently across several chronic diseases, and often those that are already well-known problems. Next slide. So next, I'll summarize a discussion in the scoping review where we looked at how scientific evidence is typically evaluated. For early life environmental risks, we're dealing with complex and uncertain science. There are complex biochemical influences on multiple, interrelated, and developing, and therefore changing systems. And then for chronic diseases, we are looking across the entire life course. We need to consider low-level chronic exposures to mixtures where exposure occurs through multiple media, all of which can change over time and location, and some populations are more exposed than others. We're dealing with causal webs, not linear systems. There can be many-to-many relationships. For example, the scientific practice of removing confounders can actually eliminate co-causal factors and weaken or misrepresent true associations. The best example is lead, where early studies factored out socioeconomic status when in fact there are complex and bidirectional relationships between the lead exposure itself, developmental neurotoxicity, and social enrichment or deprivation. And of course, we cannot run controlled experiments on children or fetuses in utero to fully understand environmental risks and establish causation, nor would it now even be possible to run the gold standard test of a randomized controlled trial for endocrine disrupting chemicals, because there is literally no human population on the planet that is unexposed to low levels of these chemicals. Next slide. So we also looked at the fact that type 2 errors occur frequently. So to remind ourselves, scientific investigations are focused on avoiding type 1 errors for many good reasons, so that we avoid concluding an association exists when it doesn't, or a false positive. But type 2 errors, where causal associations are missed, happen a lot in environmental cases. This issue has been looked at many times. In 1991, Needleman and Bellinger looked at studies investigating lead and found 6 flaws in study design that are focused on avoiding type 1 errors that contributed to type 2 errors. Again, in 2005, the review noted here looked at a wide range of studies, including experimental animal studies and observational studies in wildlife and humans, and they showed that the pressure to avoid type 1 errors created a systematic bias towards type 2 errors. And then the European Environment Agency in 2001, and again in a report released last month, they these are very large reports about the need for greater precaution in environmental decision making. They document multiple examples of environmental cases where there's the same systematic bias towards type 2 errors, that is, missing causal associations in environmental cases. Next slide. So let's look at where environment and health, environment meets public health in all of this. Our approach in the scoping review was to look at several chronic diseases by describing their multiple risk factors. We put our more detailed look at environmental risk factors, especially in early life, into that broader context. In public health, a risk factor is defined, as noted here, from the Chronic Disease Risk Factor Atlas published by the federal government. You can see it includes behavior, lifestyle, environmental exposures, and genetics, so it's fairly comprehensive. But note that it says on the basis of epidemiological evidence, the risk factor is known to be associated with the condition in question. So there's two problems with this definition. If the term environmental exposure were shortened to environment, then it might begin to include the social environment, but it says environmental exposure, which is important. But this definition doesn't sufficiently recognize the primacy of the social determinants of health, especially including the fact that poverty is not a lifestyle choice. For environmental risk factors, by the time sufficient epidemiological evidence is available, first, this evidence is very difficult to obtain. Cross-sectional or observational studies are often dismissed. Longitudinal studies require years of contamination and exposure to uncover associations. And once that's obtained, it can be far too late to achieve prevention. And notice the word prevent is in this definition. It may even be too late or impossible for environmental problems to be cleaned up. So next slide. So I'll give the last word on this subject to this guy who, in response to a consultation on new directions at the National Institutes for Environmental Health Sciences, points out that when we have a positive finding in an epi or a clinical study, that's a failure in preventive medicine policy. So as I noted, it would never be acceptable to run randomized controlled trials on children, much less fetuses, to figure this out. So we've got unavoidable uncertainty and frequent complexity in environmental cases. And so we've got serious public health implications in demanding a high degree of scientific certainty, including the demand for epidemiological evidence to complement animal or laboratory evidence before taking preventive or precautionary action. Next slide. I'll turn now to the endocrine disruption science and implications for toxicology, including its use in regulatory responses. Next slide. So recapping from the second webinar, the scientific investigation of endocrine disrupting chemicals has expanded rapidly over the past 10 years. It's reviewed in this statement from the Endocrine Society and in a large report released last month from the World Health Organization and the United Nations Environment Program. Endocrine disruption can occur along diverse endocrine pathways that are highly conserved in wildlife and humans, meaning that animal data are going to probably do a good job of predicting effects in humans. Because of the shared properties of these chemicals and the natural hormone system, no endocrine system is immune. Overall conclusions are that strong evidence exists for adverse reproductive effects, so infertility, cancers in endocrine tissue, and birth defects, and mounting evidence exists for other effects, other endocrine effects, as listed here. The World Health Organization and UNEP report doesn't mince words, and they refer to this situation as a global threat that needs to be resolved. Next slide. So for endocrine disrupting chemicals in general and those associated with obesity and diabetes as listed here, most are persistent organic pollutants, or POPs. However, it's increasingly apparent that other non-persistent substances, as well as substances with different forms of persistence, such as happens with the perfluorinated compounds, are associated with endocrine disruption. And while they may not exhibit persistence in the way we define it, so chemicals that bind to fat and bioaccumulate in the food chain, there's a quasi-persistence that happens because of widespread use of these chemicals. And biomonitoring data confirms this constant exposure despite our ability to metabolize these chemicals. And estimates vary with the number of known or suspected endocrine disrupting chemicals, around 800, but tens of thousands are untested, and we still have enormous uncertainty. Experts point to the fact that many endocrine-related diseases and disorders are on the rise. And as we discussed in the second webinar, there's plausible evidence that the metabolic changes that can be induced by obesogenic chemicals are likely superimposed on current trends in a wide range of obesity risk factors within which these chemicals should be included. Next slide. So this slide summarizes the paradigm shift in traditional toxicology that's demanded by these chemicals. There are new mechanisms of action, and we need to measure different pathways and endpoints. Traditional toxicology protocols were not designed to generate or incorporate data about molecular mechanisms or signaling pathways that are so key to understanding endocrine disrupting effects. Timing of exposure is crucial. Effects are very subtle, with development looking normal, with functional changes at the gene or cellular level persisting after the exposure is gone. The latent disease risk can be permanent and irreversible, and even intergenerational if germline epigenetic modifications happen or where there is continued environmental exposure of the offspring. Effects occur at very low doses with nonlinear dose-response curves. There's 4 examples pictured here. There are others. And the evidence indicates the likelihood of no safe level of exposure. Next slide. So these next 2 slides summarize various assumptions that exist in regulatory approaches and some widely recognized challenges. First, we treat mutagenic carcinogens differently from other chemicals and assume, quite legitimately, that there is likely no lower threshold for mutagenic effects. But we don't make the same assumption for chemicals with non-mutagenic effects, even where they are associated with cancer, such as the evidence linking low-level prenatal exposure to bisphenol A, the latent risk of breast or prostate cancer. And in risk assessments, chemicals are assumed to have toxicity thresholds and a linear dose response, where effects at high doses are extrapolated down to a calculated threshold, where we assume no effect will occur. We assess chemicals one at a time, one disease at a time, seeking one dose or sometimes a dose range for a no effect threshold. And again, generally in whole animals or human studies, not looking at molecular mechanisms or signaling pathways, though this, of course, is changing. For mixtures, some assessments have been done or are being done, such as dioxins and mixtures of waste sites, groups of pesticides with common mechanisms of toxicity. These are mostly an exercise of studying each chemical individually and then adding up to get a combined risk profile. And this additive approach is reasonably reliable, but there's a problem here if it involves adding each dose of concern when the underlying toxicology does not also recognize limits in dose-response calculations, and endocrine disruption effects may not be caught using current approaches to mixture assessment. Again, moving targets here. This is definitely improving. So 3 more overall points. We have too narrow a focus on the halogenated chemicals. That is the persistent organic pollutants. So these are chemicals that are well known to be highly toxic. They're often linked to multiple effects like cancers, low birth weight, birth defects, developmental neurotoxicity, other developmental or reproductive impacts, and in some cases, greater understanding of the mechanism of action of these effects confirms that they occur or they're mediated through endocrine disrupting pathways. The fact that these kinds of chemicals are persistent and bioaccumulative and often highly toxic underscores regulatory priorities worldwide, including in Canada under the Canadian Environmental Protection Act, the Pest Control Products Act, and we focus on these attributes of chemicals and target them for regulatory action, including outright bans in many cases. But the endocrine disruption evidence shows we need to look at a broader range of non-persistent chemicals and also get beyond current focus on estrogenic, androgenic, and thyroid pathways to include interference with metabolism, fat storage, bone development, and the immune system. And finally, there's a lack of agreement on how to evaluate strength of evidence for associations between endocrine disrupting chemicals and health effects, and then widely accepted agreement that risk assessment approaches need to be improved. Next slide. On those last 2 issues of evaluating evidence and improving risk assessment, these 3 reports from the National Research Council in the U.S. made some important contributions. And this is a very general overview I'm summarizing from the Janssen review noted here. These reports made recommendations about the need for improvement in 4 overall areas, including addressing variability and vulnerability in human populations, updating some key assumptions made in risk assessment in light of new science, addressing cumulative risks, and addressing the low-level exposures. Most of these recommendations have yet to be implemented, though I'll talk about progress in a few areas going forward. And I can't do justice to the wide range of issues raised in these 3 reports, so I've noted on the next slide selected recommendations that are relevant to both chronic disease risk factors and to endocrine disrupting chemicals. Next slide. The first is the need to consider multiple stressors, both chemical and non-chemical, their interactions and variability across certain groups. So this would begin to address the social determinants, the many examples of how social circumstances, especially living in poverty, contribute to greater exposure, greater risk than is accounted for when risk is solely a calculation of hazard times exposure. As you might imagine, all 3 reports pointed to the need to give special attention to hormonally active compounds. They challenged some key default assumptions, such as no data being taken as equivalent to no effect, a common approach to dealing with endocrine disruption, though, again, this is gradually changing. They also noted the problem of waiting for epidemiological or animal bioassay data before considering that a risk exists. On cumulative risks, the study of phthalates recommended expanding the current approach, noted in brackets, where we look at groups of chemicals that have a common biological pathway or mechanism of toxicity. And instead, because multiple pathways can contribute to the same effect, they proposed assessing as a group all chemicals that can contribute to a common health outcome, not just those that have common mechanisms of toxicity. And finally, they recommend that all exposures, even at low levels, should be assumed to be associated with some risk, and then in a related point that it is unjustified scientifically to make a distinction between cancer and non-cancer outcomes in terms of assumptions about thresholds. Next slide. So as work has continued to address these issues, which I'll return to in later slides, clinicians and scientists have continued to speak out. I mentioned the Endocrine Society statement in 2009 calling for a more precautionary regulatory response. That statement was supported by the American Medical Association in 2009, and then in 2011, in a statement published in the journal Science, 8 mainstream scientific societies noted the need for improved testing and assessment of chemicals and multidisciplinary approaches. So also in 2011, the European Society for Pediatric Endocrinology and the Pediatric Endocrine Society supported a statement by these 8 scientific societies, and then called on their members to be alert to the possible role of these chemicals when assessing both clinical problems and research data about endocrine disease when they couldn't figure out the cause of diseases they were seeing. Next slide. So finally, in another recent statement from the Endocrine Society, they spell out the reasons why chemical assessments have to be done in the context of endocrinology. They focus on the problem with standard dose testing ranges where there may be a test done at a level 50 times lower than a toxic or lethal effect level. Even if an assumed safe or threshold level is then set 100 or 1,000 times lower than that tested level, they note that that kind of a range is not useful when the potency range of a hormone can be 10,000-fold. They point out that when threshold doses are derived from this kind of standard toxicological testing, the resulting dose is very high by endocrine standards because it is based on that sublethal dose rather than looking at the mechanistic information about the biochemical or molecular actions of endocrine disrupting substances at doses that can be more than 1 million times lower than threshold doses calculated using these standard risk assessment methods. So next slide. Moving forward, we thought the best way to complete this presentation is as a sort of a progress report to review how governments are responding, and then touch on responses within local public health departments in our outreach work and within KIPCHI, and then finally responses in clinical practice. Next slide. So I've taken a roughly chronological view through the years of expanded scientific understanding about these chemicals. Of course, government agencies all along haven't been sitting on their hands. This slide attempts an overview to capture a huge amount of work for at least the past 15 years worldwide. This is work done individually and collectively by government agencies and often in collaboration with academic scientists. We have results from population-based biomonitoring studies now going into the 5th cycle in the US and the 3rd cycle in Canada. There are surveillance studies, toxicity and toxicogenomic studies, and assessments of individual chemicals or groups of chemicals, development of all kinds of different test methods. I've noted 2 examples here of Canadian work, including this in vitro model of adipocyte development, and more broadly, lending Canadian expertise to international collaborative efforts within the OECD. I note the first example because of the relevance to our focus on obesogenic substances, but there are many other examples of Canadian efforts across all of these bulleted points, and involving scientists in Environment Canada, Health Canada, including in the Pest Management Regulatory Agency, and likely much more than I'm aware of. The overall point being that work by domestic governments, especially a huge amount of work done in the U.S., as well as international cooperation through the OECD, continues to be crucially important and supports the regulatory response to toxic substances, including endocrine-disrupting chemicals. Next slide. So I mentioned those 3 NRC reports that recommended changes to chemical testing and risk assessment. Toxicity testing in the 21st century recommended that the U.S. EPA develop a strategy to use existing information alongside in silico and in vitro high-throughput assays to prioritize further information, the further information needs, and then screen chemicals as a way of more efficiently evaluating hazard and risk, because we have so many chemicals that we need to know more about. More recently, a review was completed for the Pest Management Regulatory Agency by an expert panel on the integrated testing of pesticides. This is within the Council of Canadian Academies, though they addressed chemical testing issues well beyond the application to pesticides. They also had the benefit of being able to assess another 5 years of work worth of activity in this area. So both of these reports discuss the new technologies available and in development for chemical testing and the need to address the thousands upon thousands of chemicals where we have so little information. They both point out that we still rely heavily on chemical testing methods developed in many cases over 30 years ago that typically involve expensive, time-consuming, high-dose testing on live animals, and then the default extrapolation procedures to assumed thresholds. The Canadian report does a good job of describing these various new technologies, their strengths and shortcomings. Next slide. The major regulatory response so far to the endocrine science has been to create lists of substances known or suspected as endocrine disruptors. So the next 2 slides summarize the situation in Europe and the United States. But I should also point out that while these efforts have continued, regulatory agencies, including in Canada, have continued to evaluate and regulate chemicals, including groups of chemicals. And there are many examples of substances where endocrine disruption evidence has been considered in these evaluations, including through the use of updated testing protocols developed within the OECD to address endocrine disrupting effects. But in any case, listing efforts continue because of the potentially massive number of endocrine disrupting substances. So in Europe, starting with a working list of just 564 chemicals, they reviewed the evidence and came up with these 3 categories. The first was 66 chemicals with live animal testing showing endocrine disruption, the second with in vitro evidence, and the third with no evidence or no data, which does not necessarily mean no effect. So next slide. In the U.S., the initial approach was to create a Tier 1 list of suspected chemicals, and then they published 2 lists, as noted here, but only as those worthy of further study. They didn't say they were considered endocrine disrupting substances. And the idea was to test further, and then for those found to have endocrine disrupting potential, bump those into Tier 2 for detailed testing. But they changed course a bit in 2010-11, and instead they're taking a much larger list, the so-called universe of chemicals, and within what's called the ToxCast program, they're putting them through high-throughput testing and in vitro testing to screen for endocrine disruption potential as a means of then deciding on further detailed testing. So this is an oversimplification, huge oversimplification, but one difference from the European approach is that no chemicals have actually been labeled as endocrine disruptors within this approach, although it has the potential to dramatically speed up the entire process. Next slide. There's many other aspects to the ToxCast program and the regulatory response to endocrine disrupting chemicals in general, but focusing on this high throughput testing gets at some key issues. In terms of benefits, the first is speed. Huge numbers of chemicals and chemical mixtures can be tested. The focus is on whether metabolic pathways could be disrupted, so it can help with an early indication of disruption rather than later tests looking at the consequences of disruption. There's direct human relevance when human cell cultures are used, and tests can also be done on multiple cell types like liver, kidney, etc. And there's the potential for looking at multiple life stages. For example, there's emerging research looking at embryonic animal stem cell research. Exposures at a wide range of doses, including very low doses, can be tested, and we can also test mixtures. In a crisis situation, for example, the BP oil spill, these tests were done to assess the endocrine disrupting potential of the dispersants that were used. And there's very important applications for green chemistry. I'll just refer you to the article noted here that I also mentioned in the second webinar of a testing protocol being designed to design endocrine disruption out of chemicals as they are initially created. Okay, there's very important challenges here too. Testing of genetic material or cell cultures in vitro may not predict what might or might not happen in an intact organism or even an intact tissue, and coverage is incomplete. There are about 450 assays now. There's estimates that we'll need between 2,000 and 3,000 to cover a full spectrum of human biology. None of these tests yet account for chemical metabolism. That is, they don't approximate how chemicals are metabolized and then test for the effect of the metabolite, which is often more important for some chemicals. So continuing down this list on the right, a common thread is an inability to account for variability, whether it's population diversity, multiple exposures, or different timing or patterns of exposures. It's also still a challenge to interpret the test results and translate them into a measure of actual toxicity. Assays are so far available that are very limited in measuring epigenetic effects of chemicals, which is a serious shortcoming given the evidence about endocrine disrupting chemicals causing problems through epigenetic mechanisms. And finally, there's still the problem of knowing whether results are false negatives or false positives. Results are being compared to data-rich chemicals to validate results to avoid false negatives mostly. But it appears so far that, like environmental cases at a more macro level, false positives are going to be trickier. So, for example, one of the ToxCast assays didn't accurately pick up chemicals known to interfere with PPAR, which is a protein involved in lipid and fatty acid metabolism. And these experts were reviewing the value of the tests for whether they were going to help and assess links to obesity and diabetes. So going forward with this program, it's going to be very important as these tests continue to be used and refined that there's transparency about their use and their limitations. And they'll continue to expand, no doubt, in addressing these challenges. Next slide. So that's a very brief, fast overview. Much more is happening within the ToxCast program in the US, here in Canada, in Europe, and through OECD coordination. I'm going to conclude by recalling that our review of multiple risk factors for chronic disease prompts us to see the need for parallel measures that are precautionary and prevention-oriented to address the social determinants of health. A few examples are noted here of current efforts to create, at the national level, a poverty reduction plan and a national housing strategy. Experts note that we also need a national strategy for creating jobs and related measures to address urgent health care and health cost issues faced by those with low income. To address climate change issues and in making connections to the obesity epidemic, we need to address policies governing land use planning and the built environment and local food production. And in measures to address childhood obesity, a report released just yesterday from Ontario's Healthy Kids panel made some great, very provocative recommendations to control the marketing of junk food to kids. But their view of environment is simply the locations where food is produced, marketed, bought, consumed. There's barely a nod to the built environment issues and not a word about obesogenic chemicals. So there's much work to be done within the sphere of those addressing childhood obesity. Finally, in the words and drawing from the detailed analysis of the European Environment Agency, we need to learn the lessons of early warnings and apply science, precaution, and innovation in the face of the uncertainty and complexity of this area, particularly in response to endocrine disrupting chemicals. So I think I'm okay for time. On that note, I'm going to return the line over to my three co-authors in sequence. They are going to discuss the application of precautionary approaches in public health, our public outreach work, and in clinical practice. So starting with Lauren van der Linden from Toronto Public Health. I'm going to turn it over to Lauren.
Thank you very much. Thanks very much, Kathy. I'm going to be speaking to one aspect of the local public health response to environmental health issues, such as Kathy has outlined in this and the previous webinars. They're not specific necessarily to the early exposure, later life disease prevention context, but relevant nonetheless. And this flow chart here really depicts our experience at Toronto Public Health of the context and the elements that characterize the need to consider precautionary approaches, as Kathy has just noted. Often, when we are faced with an issue that comes to our attention, public concern is one of the main drivers. And it's not just public concern. There are many other stakeholders, whether it's non-governmental organizations, the media, counselors, politicians, or our boards of health. We may be looking to the literature, and there may be some studies that indicate health concerns. That may come from our own monitoring or from our academic partners. And quite often, as this whole talk has been about, that the state of the science may be uncertain, and there may be lacking or absent or limited kinds of protective mechanisms in place. So in these kinds of circumstances, we have often turned to consider what degree, if any, of precaution should be applied. I think this model really reflects and is parallel to the model for evidence-informed decision-making in public health that's described by the National Collaborating Center for Methods and Tools, where there is a legitimacy given to community health issues and local context in terms of being a source of evidence for consideration. So our experience has been that this combination of factors frequently lead us to look at solutions and figure out strategies from a precautionary standpoint. Next slide, please. So here's just a range of contexts within which we've applied precaution, in many cases having to tailor our responses to the needs of our communities. And for example, our fish consumption advice for women in childbearing years is a good example of that, where we had to address communities where fish is a very frequently consumed food item, much higher than the Canadian average. This is really a mix of proactive and reactive pieces of work where precaution has been applied. Not all are relevant to the children's environmental health context, but several are. In applying precaution, we've learned from a number of our examples that you need to ask important questions that aren't always asked when doing a risk assessment. We view all of the strategies proposed through a lens of equity. Do all children benefit equally? All people benefit equally? Will any children suffer from the cost of the strategies? And will all settings be able to introduce the strategies? And we also assess each proposed strategy with the recognition that environmental health is just one of many aspects of health. And as Kathy has noted in her concluding slides, that there are many other considerations that are determinants of health for children. The last bullet I'm going to speak to is my last slide, but I'll give you a little bit of context there before we switch. This reflects a reactive response to an issue that came through a member of the public and ultimately through our Board of Health, and it concerns bisphenol A. There was considerable media coverage on BPA in 2006 and 2007, and a member of the public with concerns about exposure to contaminants from food served at child care centers, and BPA was at the top of her list, approached her counselor, who brought it to the Board of Health and forwarded it as a request for a response from the Medical Officer of Health. Next slide, please. So how did we deal with that issue? Well, as I say, she'd given us a list of contaminants of concern, and the board felt it was important enough for us to address it. We undertook a reasonably thorough assessment of the evidence. So, of course, when you're applying precaution, it's not about ignoring evidence or only relying on one source of evidence. We asked questions that the regulators would be as well. Are substances hazardous? What would this exposure be at the child care setting? Can it be reduced? Can exposure be reduced? What are the risks and benefits? Are the strategies sustainable? And finally, are there equity considerations? Now, luckily, at the time when it came to us, Health Canada was also doing their review of BPA and ultimately in 2008 announced their precautionary prohibition on BPA in baby bottles in Canada, which was a help. We concluded in looking at the evidence that we probably needed to advise parents on how they could reduce their exposure to BPA where possible. But of course that's only a starting point because there is great complexity to this issue and important equity considerations. This is just sort of a slice of some of the advice we provided, notwithstanding that our primary advice to parents is to breastfeed babies. That's the best way to feed babies. But we did obviously have to pay attention to the concerns that have been raised, and we were happy with Health Canada's response to prohibit the baby bottles that contain BPA. And so we'd already had a pre-existing message about avoiding heating fluids in plastic baby bottles. But beyond that, the whole issue of the canned food conundrum, recognizing that food exposures, at that time the evidence suggested that they were the largest sources of exposure. But it's a difficult call to suggest that parents limit or restrict the amount of canned food that they give their children, and huge equity considerations of telling the public, giving them that message. So we landed on encouraging fresh and frozen food wherever possible and following Canada Food Guide recommendations. So that's a really quick sketch and overview of one particular response where we felt we had taken a precautionary approach. And I'm going to turn it over now to my colleague Franca Ursidi, who's going to talk a little bit more about the proactive work that local public health has done in partnership with KIPSHE and the great work that we've done as a partnership.
Unmute your line, Franca. *6. Uh-oh. Okay, we got a problem here. Franca, we're not hearing you. I'm gonna do Franca's speaking notes because we're not hearing her. Should I go ahead with that, Adele?
Yeah, that sounds great.
Yeah, sorry, Franca. I don't know what happened there. Okay, so we're just going to briefly highlight KIPSHE's outreach approach, illustrate how local public health units use the outcomes of this approach with their clients and day-to-day interactions with the community. KIPSHE is challenged, as I suspect many of us are, by synthesizing very high literacy, scientific and technical information into information that's meaningful to parents and caregivers, that they can apply in day-to-day activities and take action to prevent or reduce exposures. We've got this Top 5 Tips project. It was undertaken to identify in an evidence-informed way the top 5 areas where we thought that exposure was of greatest concern and where people could act on it and prevent their own exposures in 5 areas. So we called it Bust That Dust, Get Drastic with Plastic, Dish Safer Fish, Renovate Right, and Go Green When You Clean. The project includes the development of pull-out brochures, a pull-out brochure that was inserted into today's Parent magazine, a video and some rack cards, as we call them, that provide quick tips in those specific areas and their takeaways for clients in areas of specific interest. Public health staff provide these materials and they use them with their, the public health staff have these materials, they use them in group settings with clients or one-on-one service delivery, generally in prenatal and parenting programs. For example, the Healthy Babies, Healthy Children program. Both public health nurses and family home visitors go into the homes of high-risk families. They provide support and information on various issues, including reducing exposures. These families are generally vulnerable. They're living in poverty, or they may be newcomers that don't have many community supports or language skills. We know that increased vulnerability can also result in increased exposure. So we have simple, inexpensive tips. In some instances, people may already be including them as part of their day-to-day activities. They're simple and they lend themselves for use with novel communication tools like social media. I didn't mention here, we also have a video that conveys this entire approach as well. So, for example, Peel Public Health has used these tips on their Facebook page, and they often get shared that way, reaching an even bigger community. So, Sorry about that, Frank. I don't know what happened there. I'm going to pass it over now to Lynn Marshall to round us up with clinical issues.
Yes, and I hope I'm unmuted.
You're fine. Go ahead.
Okay, good. The Ontario College of Family Physicians has an environmental health committee, of which I'm a member, and we use the precautionary principle in clinical practice for very good reasons, to protect the most vulnerable of our persons, patients, and to advise individuals, just like Lauren said in public health, to advise individuals expressing concern about exposures for themselves or the family members, but also to improve quality of life for the sick, since health is a multi-determinant model. There are multiple determinants of health, as we've already talked about a lot. So we have to use the precautionary principle for those purposes. While we're doing that, we have certain considerations. The strength of the scientific evidence for association of exposures with adverse outcomes is very important to us. And the severity and frequency of adverse outcomes in the people before us is very important. Weighing with the person the benefits and costs of action or lack of action or partial action, as informed professionals weighing the benefits and costs with people. Also, we have to consider the feasibility of reducing exposure and availability of resources for reducing exposure. And so I'm just going to give you a few examples of application of the precautionary principle in clinical practice that we've made use of at the Environmental Health Committee. First of all, the science. We consider that very important that we be well informed, and our members of the Ontario College of Family Physicians are well informed about the health effects of certain problematic substances. So, for instance, pesticides, we've done a systematic literature review twice on the health effects of pesticides, and the outcome was not good. We're very concerned about that. And so we then acted in conjunction with other organizations in the public and charitable organizations to advertise or make known the effects of the science of health effects of pesticides. The same with urban sprawl. The built environment is very important, as is commuting. And climate change, and the Air Quality Health Index, which will improve our knowledge of what activities to do in the outdoor air, depending on our personal risks. The nuclear energy industry, and these are just a few. We have looked at lots of other contaminants and chemicals, and then we promote the findings on our website and at local, provincial, national, and international conferences. The second thing was, I mentioned already, vulnerability. And so the most concern regarding the vulnerability is the age of the children, the unborn, infants and children, and older children and adolescents. Fortunately, in family practice, most family physicians use the Rourke Baby Record and the Greek health records to question parents and about their kids when they come for regular child visits or on an acute visit for some problem. So we reviewed the evidence thanks to Health Canada Ontario. We reviewed the literature about the most concerning exposures for those age groups, from unborn infants up to the age of 5 for the Rourke Baby record, and from ages 6 to 17 years for the Greek Health record. And then we were in the process of getting those new findings incorporated into the records, and so they will flag environmental exposure concerns for the family physicians on their visits with their patients. Informing professionals we consider very an important part, because how are they going to answer questions from their people in their practice if they are not knowledgeable? So we publish articles in peer-reviewed journals on taking an environmental history, exposure history, and how it would be applied for various environmental contaminants, about climate change and the impacts of lead. And we as well develop environmental health days. So the doctors that come to these programs will get more and more informed every year. And we've just completed a 4-module teaching program on environment-linked illnesses, prevention, diagnosis, and management from preconception to old age just this past weekend. And it was quite popular, and we were very pleased at the turnout. And so hopefully we will go on a traveling road show to deliver these programs to family physicians throughout Ontario and perhaps in other provinces as well. In addition, we link with the College of Family Physicians of Canada, which has an environmental health committee now, last couple of years, and WONCA, which is it's World Organization of National Colleges, Academies, et cetera, World Organization of Family Physicians. So we link with them too, so that we can spread the word to other federally and internationally about exposures of concern. Resources, we've developed and distributed resources of our own, exposure history forms and pamphlets, for instance, on lead and mercury on our website and in conferences. But also we value our partnership in KIPG. So we distribute via website and courses and conference of the KIPG pamphlets, fact sheets, and video. And to serve persons with varying languages and literacy levels, because that's another way that people are more vulnerable. And so for much of the work, we thank Health Canada Ontario Division for funding and moral support while we do this. That's it. Back to you, Kathy.
Okay, thanks, Lynn. I'll just wrap up these slides. I've just done another bunch of references for most of the stuff that I did. If there's other things people are interested in terms of resource material or source material we've used, we can certainly send it out. And then just a final thank you slide and open this up to questions. So thanks, everyone.